So good afternoon, everyone. I think we are a little bit late, and only 14 students have joined. I was thinking कि some more student would have joined this class, but uh, only very few students have joined today's class. I don't know what is the reason. So in previous class, we had understood about the different type of the oscilloscope, and we discussed about the dual beam oscilloscope and dual trace oscilloscope. So today we are going to discuss about the sampling oscilloscope. So, as far as the sampling oscilloscope is concerned, an ordinary sampling oscilloscope has a bandwidth of the 10 megahertz generally, and the high frequency performance can be improved by means of the sampling the input waveform and reconstructing the shape of the sample. तो यहाँ पे हम जो इनपुट वेवफॉर्म है उस वेवफॉर्म को हम सैम्पलिंग के थ्रू उसको रिकंस्ट्रक्ट करते हैं, उसको चेंज करते हैं इनपुट वेवफॉर्म को थ्रू द सैम्पलिंग, and the signal to be observed is sampled, and after the few cycles the sampling point is advanced and the another sampling is taken. Means we are taking the some samples of the input signal, then we are processing, then again we are taking samples of some input signal, then again we are processing, and like that we are doing in this case. So the shape of the waveform is reconstructed by joining these samples. तो बाद में फिर इन सारे samples को हम लोग join कर लेते हैं and the level together, and the sampling frequency may be as low as the 1/10 of the input signal frequency. Understood? So for example, if the input frequency is 100 megahertz, so the bandwidth of the CRO vertical amplifier can be as low as the 100 megahertz. तो जो भी उसकी फ्रीक्वेंसी, जो भी उसकी बैंडविड्थ होती है ऑसिलोस्कोप की, that is basically the bandwidth of that the vertical amplifier. So as many as the 1000 samples are used to reconstruct the original waveform. So this is the diagram of the sampling oscilloscope. You can see here the input signals are taken and they are going to the sampling gate. यहाँ पे उनके कुछ samples लिए जाते हैं through the sampling gate, and the signal is for the sampling gate is given from the voltage comparator, output of the voltage comparator, and the sampling. This is the sampling pulse. Means कि इतनी pulse duration के लिए ही हमें sample लेना है, right? And that sample is given to the vertical amplifier, and after that it is given to the vertical deflection plate, right? From the bottom one you can see there is an trigger input, and trigger input basically trigger the oscillator start oscillating, and it starts giving the sinusoidal signal, and then it is given to the ramp generator. This sinusoidal signal is converted into the ramp generator, and the output of the ramp generator is given to the voltage comparator, right? And from there the output is taken to the attenuator also, and output of the voltage comparator is given to the sawtooth waveform generator or staircase generator, right? So that is the staircase generator output is given to the horizontal deflection plate. So this is the way how we are just producing the sampling oscilloscope here. So here the input waveform is applied to the sampling gate, as we can see in the diagram, and the input waveform is sampled whenever a sampling pulse opens the sampling gate, and the sampling pulse is basically provided by the voltage comparator, right? So sampling basically here must be synchronized with the input signal frequency. That is very, very important here in this case. That must be the synchronized, and the signal is delayed in the vertical amplifiers, allowing the horizontal sweep to be initiated by the input signal. That is very crucial at this point. So this is the way how the sampling is done and the sampling oscilloscope is working. So this block diagram is sufficient for the understanding of the sampling oscilloscope. Let us see how the sampling is done here. Further, it is being explained. The various waveforms for each block of the sample oscilloscope, it is shown here. So you can see here there is a input waveform, and there is a trigger pulse also is given, and there the sampling pulse is also given, and the sweep ramp generator is also provided here. So you can see the input waveform, and input waveform is taken into the some of the samples के basis पे लिया जाता है. So at the beginning of the sampling cycle, the trigger pulse activates an oscillator and a linear ramp voltage is generated, that I told to you, and this ramp voltage basically is applied to the voltage comparator, which compares the ramp voltage to the staircase generator, right? So this is the way how this sampling oscilloscope is working. Now the next is the storage oscilloscope. So जैसा नाम है वैसा काम है इसका. Storage oscilloscope means it basically this oscilloscope stores the image of the input signal. which is to be displayed on the screen, or the output on the screen is basically stored for the some period, some millisecond to the some hours. So it is known as the storage oscilloscopes. It has the some you can say that the memory is provided in this kind of the oscilloscopes to stores the input informations. So the storage targets can be distinguished from the standard the phosphor targets by their ability to retain the waveform pattern for a long time. As I told you that the image basically persists on the face on the screen from the few milliseconds to the few hours, and that is only possible with the help of the phosphor material, phosphorus material, which we are using here, and that is known as the phosphorescence for the retaining the information for the period how much it can retain the image on the screen, right? So and that is also known as the persistence, phosphorus persistence basically. So the two stage techniques are used in oscilloscope CRTs, mass voltage and the phosphorus storage. So the mass storage oscilloscope uses a here there are the two type of the technique we are using for the storage oscilloscope, that is the mass storage and phosphorus storage. So first one is the mass storage oscilloscope. If you take, so here in this case, a dielectric material is deposited on the storage mesh as the storage is target. तो डायलेक्ट्रिक मटेरियल को हम डिपॉजिट करते हैं यहाँ पे, एंड दिस मैश इज प्लेस्ड बिटवीन द डिफ्लेक्शन प्लेट एंड द स्टैंडर्ड फॉस्फोर टारगेट इन दी सीआरटी. तो यानी जो डिफ्लेक्शन प्लेट्स है और उनके और जो फॉस्फोर मटेरियल है स्क्रीन जो कोटेड है हमारी फॉस्फोरस मटेरियल से, उसके बीच में द मैश इज प्लेस्ड. ये जो मैश है ये इसको बीच में मैश स्टोरेज जो है दैट इज प्लेस्ड इन बिटवीन these two, that is the deflection. Our last deflection plate is a horizontal deflection plate. After that we place a screen, so between these two we place the this mesh we placed in between these two, and the writing beam which is to be focused which is the focused electron beam of the standard CRT charges the dielectric material positively where it hit, जो बीच में है दोनों को. So what happens, the storage target is then bombarded with the low velocity electron from a flood gun. तो जो हमारे स्क्रीन के ऊपर जो कोटिंग है, अब क्योंकि टारगेट फर्स्ट जो इलेक्ट्रॉन बीम है जब फर्स्ट बेसिकली बोम्बार्ड फर्स्ट जो हिट करती है वो बीच में मैश को हिट करती है, एंड आफ्टर दैट इट इज हिटिंग द स्क्रीन, सो इट गोज विद द वेरी लो वेलोसिटी टू द स्क्रीन. So the storage target is then bombarded with the low velocity electron from a flood gun, and a positive charge areas of the storage target allows these electron to pass through the standard phosphor target and thereby reproduces the storage image on the screen. तो इस तरीके से यहाँ पे जो स्क्रीन पे जो इमेज जो बनती है, that is the image on the screen is basically stored for the long duration. So basic idea is the screen is stored for the long duration, as you can see in the diagram also. So there is a horizontal deflection plate, then there is a flood gun. So this flood gun is basically different from the writing gun. तो ये जो फ्लड गन है ये राइटिंग गन से डिफरेंट होती है. राइटिंग गन का काम है उसको इमेज को डिस्प्ले इमेज को राइट अप करना ऑन द फेस ऑफ द स्क्रीन, एंड द फ्लड गन का काम है उस इमेज को इल्यूमिनेट करना, उस इमेज को जो है वहां पे स्टोर करना फॉर द लॉन्ग ड्यूरेशन. दैट इज द पर्पस ऑफ द फ्लड गन. So as you can see here, the two flood guns we are seeing here, and there is the collimator electrode which stores basically the deflected electrons जो electron wall से टकराते हैं left side right side में. So this is the electrode which stores those electrons, and there is a collector mesh as I told you that is placed in between the screen, the storage mesh, phosphorus screen, that is the collector mesh, and the storage mesh that is in between the horizontal deflection plate and the screen. So as you can see, the phosphor storage oscilloscope uses a thin layer of phosphor to serve both as the storage and as well as the display elements. So both are served with the same thing. So the mesh storage, if we talk about, it is used to display the very low frequency signals and finds many application in mechanical and the biomedical fields. ये जो mesh storage है इसके अंदर, and the conventional scope has a display with a phosphor persistence. जो conventional जो हम laboratory में use करते हैं, they have the display with a phosphor persistence ranging from a few microseconds to the few seconds. But in mass storage oscilloscope, we can store the image for a few hours even. So the persistence can be increased to a few hours for from a few seconds with this technique. With this technique. So a mass storage oscilloscope, as shown in the figure, contains a dielectric material deposited on a storage mesh. राइट तो जो स्टोरेज मैश है आप जो देख रहे हैं उसके ऊपर एक डाइलेक्ट्रिक मटेरियल जो है हम उसके ऊपर एक डाइलेक्ट्रिक मटेरियल की लेयर उसके ऊपर लगाते हैं एंड द डाइलेक्ट्रिक मटेरियल इज डिपॉजिटेड ऑन द स्टोरेज मैश a collector mesh, flood gun, and a collimator. Collimator, basically, these three things we are also using in addition to all the elements of the standard CRT. स्टैंडर्ड सीआरटी के अलावा ये तीन चीजें हम लोग यूज करते हैं स्टोरेज ऑसिलोस्कोप में. दैट इज स्टोरेज मैश, there is a dielectric collector mesh. The dielectric is deposited on the storage mesh, and there is a flood gun and collimator. So that storage target basically thin film deposition of dielectric material such as the magnesium fluoride we are using as a dielectric material on the storage mesh and make use of the properly known as the secondary emission. The writing gun each is a positively charged pattern on the storage mesh or the target by knocking off the secondary emission electrons. I think you are understanding this concept. And because of the excellent the insulating property of the magnesium fluoride coating, the positively charged patterns remain exactly in the position where it is deposited. तो जहां पे वो डिपॉजिट हुआ है तो So sorry for the interrupt, actually call आ गया था. So we were discussing about the basic elements of the storage mesh CRT. So this we discussed. Okay, so I'll share this slide, I think, and you can go through this in a very simplified way. It is written. So in the next diagram, you can see the two flood guns, and the two flood guns are basically emitting the now the flooding the screen, flooding the storage mesh basically, and they are illuminating the entire image which is represented on the screen with the writing gun. तो उस पूरी इमेज को ये इल्यूमिनेट कर देते हैं, और उस इल्यूमिनेट को करके ये पॉजिटिवली चार्ज हो जाता है, और पूरी स्क्रीन को इल्यूमिनेट करने से वो जो जो इमेज है, दैट इमेज परसिस्ट ऑन फॉर ए फ्यू आवर्स. तो यहाँ पे वो कुछ घंटे तक वो इमेज यहाँ पे रह सकती है. सो विद दिस हेल्प द स्टोरेज mesh CRT, we can retain the image for a long hours, for the long period. So this is another diagram shows a display of the storage charge patterns on the mesh storage. So as you can see, this is the collector, the collimated flood electrons. Then they are going to the based on the positive charges, and this is the storage surface. तो जहाँ पे वो टकरा रहे हैं, strike कर रहे हैं, so that the positive that is the surface positive charge is created, and some of the secondary electrons are also coming from it. So that creates a negative charge on the storage mesh, storage surface. So which is the electron, and then these are basically passing. Some of the electrons are passing between this, and they are just striking on the phosphor material on the screen, as you can see. So display of the storage charge patterns on a mesh storage. And this is sometimes also known as the digital storage oscilloscopes also. So digital storage oscilloscopes are available in processing and the non-processing types, and the processing type inputs built in the computing power, which takes the advantage of the fact that the data is already in the digital forms. So क्योंकि digital नाम आ गया, तो it will have some computational capability also includes in this digital storage oscilloscopes. And the inclusion of the interfacing and the microprocessor provides a complete system for information acquisition, analysis, and the input. The processing capability ranges from the simple functions such as the average, area, RMS, etc. So ये सब processing is done digitally in the digital storage oscilloscope, and to complete the fast Fourier transform spectrum analysis capability. The entire the processing, as I told you, that the processing is being done digitally inside the processor in digital storage oscilloscope. Through this you can go through the whole slide, and the whole material you will understand in a better way. Both is simplified way it is written here, right? And again, this some diagram is given for the digital storage CRO. That is, there is the inputs are given, that is input 1, 2, 3, 4. The inputs are given, that this is a 4-channel. This is the 4-channel digital the storage or CRO. So here is the first channel, and the second channel, third channel, fourth channel, and the external trigger is given to the trigger input. After the 4-channel, there is after the 4 inputs, it is given to the amplifiers. Then it is given to the 10-bit A to D converter. So the input is in the analog form. So ये analog form के input को मुझे digital में convert करना है. So that I have to use the digital 10-bit A to D converter I am using here. So 10 bit A to D converter we are using, which is converting the analog signal into the digital form, and then it is given to the record controller. So record control is there, that is the processor we are using here. So then after that it is given the 1024 memory we are using, the 1 kilobit memory we are using here separately, and there is a output control is there. Then we are using 10-bit DAC, digital to analog, and then the output of the DAC, क्योंकि जो मेरा डिस्प्ले होने वाला है, जो मेरी क्या जो वर्टिकल डिफ्लेक्शन प्लेट पे जो अप्लाई होने वाला है, दैट सिग्नल इज बेसिकली इन एनालॉग फॉर्म. तो उसको फिर डिजिटल सिग्नल को फिर मुझे एनालॉग में कन्वर्ट करना है. सो दैट्स व्हाई द आउटपुट ऑफ द मेमोरी इज गिवन टू द आउटपुट कंट्रोल इंटरफेस, एंड देन इट इज गिवन टू डिजिटल टू एनालॉग कन्वर्टर. तो एंड डिजिटल टू एनालॉग कन्वर्टर इट इज कन्वर्टिंग, एंड इट इज गिवन टू द CRO as a digital output. So this is the complete block diagram for the digital storage or CRO or oscilloscope, as you can see here, right? So please go through this material, you will understand nicely here. And this is the digital storage scope of features we are discussing. That is, sampling rate is the 20 mega samples per second per channel. Maximum captures is the both channels. Pre-trigger 25%, 50%, 75%. Roll mode is given. Single shot is given. Digital sweep rate. And these are the basically specifications for the digital oscilloscopes and features. These are not necessary for to be written in the exam. But this is for your basically understanding के लिए दिया हुआ है, ताकि आपको एक आइडिया लगे, फेयर आइडिया कि यस कि उसका जो डिटेल्स है, जो जो डेटा है अंदर, जो स्पेसिफिकेशंस है वो किस प्रकार से होते हैं. So that is the basic idea behind it. Hope you would have understood about the CRO. In the different type of the CRO probes के बारे में ये टोटल रियल हमने यहाँ पे डिस्कस किया, और बस इतना ही आपके सिलेबस में है. You can go through this material and you will be able to write sufficient in your exam. और इसी के अंदर से आपका एग्जाम में पूछा जाएगा जो भी ये कंटेंट यहाँ पे जो हम लोगों ने डिस्कस किए हैं. So with this now I'll take the attendance and we'll keep the material up to here. Today attendance is very short. I don't know why it is very short. What is the reason behind it? So we'll discuss. So is it clear to everyone?
Yes sir.
ओके तो मैं ये स्लाइड अभी शेयर कर देता हूँ. आई थिंक ये मैंने शेयर नहीं की है. सो मैं अभी इसको अभी गूगल क्लासरूम पे नाउ आई एम शेयरिंग दिस एंड यू जस्ट गो थ्रू दैट एंड अंडरस्टैंड. चलो ओके, बाय टू यू ऑल.